Hmm. Hey guys, good evening and welcome back again to your Unacademy NEET English channel. I hope all of you are doing great, having a good time. So people, quickly let me know in the chats if all of you can hear me. If I am perfectly audible and visible to every one of you. Quickly let me know in the chats with some fire emojis, thumbs ups, whatever you would want to put in the chats. Let me know quickly in the chats, people, if all of you can hear me, if I'm perfectly audible and visible to every one of you. Good evening, guys, good evening. So today it's going to be the part 2 of the chapter redox reactions, right? We are done with the first session of the chapter redox, in which we discussed about the oxidation state, the rules to calculate oxidation state, different types of structures, like how do we identify the oxidizing agent, reducing agents, its application part, all that was done in the last session, right? So today it's going to be again a super important session, right, when it comes to the chapter redox reactions. So first of all, let me know in the chats how many of you are done with the first session of the redox. Just say yes or no in the chats. I just want to know. I just want to know. Some people are asking about the atomic structure part 2. In 2 to 3 days, you'll be getting the recording of the atomic structure part 2 as well. Okay, don't worry. You'll be getting it. You will be getting it. In just 2 to 3 days, I'll post one recording of the atomic structure part 2, wherein you'll be completing your whole chapter. Already, I believe, like 70 to 80% chapter is done in the part 1. And in the part 2, I mean, there are a few topics that are left, which I'll be posting in coming days. So let me know in the chats. If all of you watched the first session of the chapter redox, then I'll move ahead. Yes. Exactly. DPP of this particular chapter, I mean the problem practice sheet of this particular chapter, I'll be sharing with you once we'll be done with this. Once we are done with this chapter, okay, this chapter redox reaction in total, it's going to take 3 sessions, out of which 1 we have taken. Today is the second one. And after 2 days, it's going to be the third one. The third lecture is going to be the last lecture of the redox reaction. And on that day itself, I'll share the problem practice sheet with you on my Telegram. I hope I'm clear to everyone. I hope I'm clear to everyone. Yeah? Perfect, guys. Let's get going then. Let's get started with the today's session. I think I'll turn off few lights, right? Let the night mode begin. Yeah, now it's fine, I believe. Now it's fine. Just a second, let me fix all these things. This is fine. Yeah. All right, people. So let's get going then. Let's get started with the today's session. And my dear students, our first topic of the today's session, what exactly it's going to be? The most important topic of this particular chapter, what is that? That is equivalent mass. That is equivalent mass. Yes, even JEE students can also watch this session. Yes, absolutely. Okay. My dear students, what the term equivalent mass is exactly all about. What I'll be doing, first of all, I'll be writing the definition of the term equivalent mass. Then I'll make you understand what this equivalent mass exactly is all about. Try to understand each and everything very, very, very carefully, because this session is going to be the most important session of the chapter redox. Okay. So first of all, as far as the definition of the term equivalent mass is concerned, equivalent mass is defined as that mass of the substance that mass of the substance which can combine. That mass of the substance which can combine or displace. That mass of the substance which can combine or displace either 1 gram of hydrogen, or 8 grams of oxygen, or 35.5 grams of chlorine, or 108 grams of silver, or 80 grams of bromine. 80 grams of bromine. This is the definition of the term equivalent mass. Equivalent mass is defined as that mass of the substance which can combine or displace either 1 gram of hydrogen, or 8 grams of oxygen, or 35.5 grams of chlorine, or 108 grams of silver, or 80 grams of bromine. Now, what exactly is meant by this particular definition? How can we understand this particular definition? See guys, in order to make you understand this particular definition, look here and understand things carefully. My dear students, for example, I'm writing a reaction, a general reaction I'm writing over here. Let's say the reaction is like this. N2 gas plus 3 times H2 gas. What does it give us? It gives us 2 times NH3 gas. Okay, this is the reaction which I've taken over here. For example, I'm asking you to calculate the equivalent mass of nitrogen. Let's say this is something which I'm asking you to calculate the equivalent mass of nitrogen. Okay, I'm asking you to calculate the equivalent mass of nitrogen. Now, my dear students, over here in this particular reaction, if you analyze carefully, if you look carefully, nitrogen is combining with hydrogen. In this particular reaction, nitrogen is combining with hydrogen. Okay. Look at the definition of the equivalent mass. Equivalent mass of the substance is nothing but it is that mass of the substance which can combine or displace either 1 gram of hydrogen or 8 grams of oxygen, etc., etc. Now look carefully. Understand carefully. My dear students, if I ask you, what is the molar mass of H2? You will say the molar mass of H2 is 2 grams. Molar mass of H2 is 2 grams. What does that mean? That means the mass of 1 mole of H2 is 2 grams. That means the mass of 1 mole of H2 is 2 grams. Now tell me one thing. Do we have 1 mole of H2 here or 3 moles of H2? We have got 3 moles of hydrogen here. My dear students, if the mass of 1 mole of H2 is 2 grams, therefore the mass of 3 moles of H2 is going to be 3 2s are 6 grams. So instead of this 3 moles of H2, I'll just write 6 grams of hydrogen. I'll just write 6 grams of hydrogen. Now tell me one thing. Tell me one thing, people. What is the molar mass of N2? Molar mass of N2 is nothing but 28 grams. That means the mass of 1 mole of N2 is 28 grams, right? Look here. I have got just 1 mole of N2 over here. So instead of this 1 mole of N2, I'll just write 28 grams of what? 28 grams of nitrogen. Right? Now, people, how exactly you are going to read this statement? That's important. How you are going to read it? You'll read it like this. As per the stoichiometry of the reaction is concerned, I can say 6 grams of hydrogen. 6 grams of hydrogen combines with 28 grams of nitrogen. 6 grams of hydrogen combines with 28 grams of nitrogen. If you use the unitary method, my dear students, if 6 grams of hydrogen are combining with 28 grams of nitrogen, what do you think about 1 gram of hydrogen? Can I say 1 gram of hydrogen would have combined with 1 gram of hydrogen would be combining with 28 divided by 6, which comes out to be 14 divided by 3 grams of nitrogen. Absolutely, I can say that. If you look carefully, what is this particular term? If you look carefully, what is this particular term? I would say this particular term, it is basically that mass of nitrogen. It is basically that mass of nitrogen which has combined with 1 gram of hydrogen. And as per definition, that mass of substance which combines with 1 gram of hydrogen, what do I call that as? I'll be calling that as equivalent mass. So my dear students, can I say over here, this 14/3, it is nothing but, it is the equivalent mass of nitrogen. Yes, the equivalent mass of nitrogen came out to be 14/3 grams, right? As per definition, this is the mass of nitrogen that has combined with 1 gram of hydrogen. And as per definition, that mass of substance which combines with 1 gram of hydrogen, I'll be calling that as the equivalent mass. So this is nothing but equivalent mass of nitrogen over here. I believe I'm clear. Okay. Let me give you one more example so that you can understand it properly. Look carefully, guys. For example, I'm writing a reaction like this. Let's say I'm writing the reaction Mg plus O2. What does it give us? It is going to give us MgO. If I first of all try to balance this particular reaction, this will be 2 times and this will be 2 times. Now this is a balanced chemical equation. My dear students, for example, I need to calculate the equivalent mass of magnesium. Let's say I need to calculate the equivalent mass of magnesium, right? Look carefully, people. Look carefully. This magnesium over here is combining with oxygen. This magnesium is combining with oxygen. So first of all, since magnesium is combining with oxygen and I need to calculate the equivalent mass of magnesium, right? What does it mean exactly? Equivalent mass of magnesium means that mass of magnesium which has combined with either 1 gram of hydrogen, but right here I'm not going to talk about 1 gram of hydrogen because magnesium is combining with oxygen, so I'll be using this particular statement of the definition. I'll try to calculate that mass of magnesium which has combined with 8 grams of oxygen, because magnesium in this particular reaction is combining with oxygen. So I'll try to calculate that mass of magnesium which has combined with 8 grams of oxygen. And let me tell you, that mass of magnesium which has combined with 8 grams of oxygen, what do I call that as? I'll be calling that as equivalent mass of magnesium. For example, try to understand carefully, guys. First of all, what is the molar mass of O2? Molar mass of O2 here is 32 grams. That means the mass of 1 mole of O2 is 32 grams. I'll be writing 32 grams of oxygen. 32 grams of oxygen combines with, what is the molar mass of magnesium? Molar mass of magnesium is 24 grams. That means mass of 1 mole of magnesium is 24 grams. Now you tell me, if the mass of 1 mole of magnesium is 24 grams, what will be the mass of 2 moles of magnesium? Mass of 1 mole of magnesium is 24 grams, so the mass of 2 moles of magnesium will be 48 grams. So I'll be writing 48 grams of magnesium over here. Now, my dear students, how exactly you're going to read this statement? Again, in the similar way. Have a look. 32 grams of oxygen combines with 48 grams of magnesium. This is something which stoichiometry is telling me, right? 32 grams of oxygen combines with 48 grams of magnesium. Therefore, 1 gram of oxygen would have combined with 48 divided by 32 grams of magnesium, right? Therefore, I can say 8 grams of oxygen. Therefore, 8 grams of oxygen would have combined with 48 divided by 32 multiplied by 8, right? 8184. The value comes out to be 12 grams of magnesium. If you look on this particular statement carefully, what did I calculate? What is this particular term? I would say this is the mass of magnesium. This is the mass of magnesium that has combined with 8 grams of oxygen. And as per definition, that mass of substance which can combine with 8 grams of oxygen, what do you call that as? You'll be calling that as equivalent mass. So my dear students, this 12 grams over here, I'll be calling this as equivalent mass of magnesium. This is the mass of magnesium that is combined with 8 grams of oxygen, and as per definition, that mass of substance which combines with either 1 gram of hydrogen or 8 grams of oxygen, what do I call that as? I'll be calling that as equivalent mass of that substance. If it is clear, let me know once in the chats quickly. If it is clear, let me know once in the chats quickly. Quickly, people, everyone. Let me know in the chats quickly. Till then, I'm going to write certain basic questions. As per the definition is concerned, let me see exactly if you can solve that or not. So, let me know once in the chats if all the things are clear. Let me know once in the chats if all these basic things are clear till here. I want every one of you to let me know quickly. Let me write down a question over here. The question is like this, simple question. This is sulfur forms two compounds. Sulfur forms two compounds. Sulfur forms two compounds. S2Cl2 and SCl2. Sulfur forms two compounds, S2Cl2 and SCl2. In the question, they are saying that the equivalent mass of sulfur in S2Cl2 is equal to 16 grams. Calculate the equivalent mass of sulfur in SCl2. Let's say this is the question. Calculate the equivalent mass of sulfur in SCl2. How exactly you're going to solve it? See guys, if you look at the first statement says that the equivalent mass of sulfur in S2Cl2 is 16 grams. I've got nothing to do with that. Look at something what I'm supposed to calculate. I'm supposed to calculate the equivalent mass of sulfur in SCl2. I'm supposed to calculate equivalent mass of sulfur in SCl2, right? So I'll be writing the reaction like this. I'll write sulfur plus 2 chlorine atoms. Sulfur plus 2 chlorine atoms gives me SCl2. This reaction is balanced. This reaction is balanced. What am I supposed to calculate? I am supposed to calculate equivalent mass of sulfur in SCl2, right? Now, my dear students, if you look carefully, sulfur is reacting over here. Sulfur is combining with what? Sulfur is combining with chlorine. If sulfur is combining with chlorine, that means this chlorine is going to be my reference to calculate equivalent mass of sulfur. Chlorine is going to be my reference to calculate the equivalent mass of sulfur. So what exactly I'm going to check? I am going to check that mass of sulfur which has combined with 35.5 grams of chlorine. Look at the definition once. That mass of the substance which can combine with 35.5 grams of chlorine, what do you call that as? You'll call that as equivalent mass, right? So over here, sulfur is combining with chlorine. So this chlorine is going to be my reference, with respect to which I'll be calculating the equivalent mass of sulfur. Try to understand now. Use the stoichiometry again. My dear students, tell me one thing. What is the molar mass of Cl? It is 35.5 grams. That means mass of 1 mole of Cl is 35.5. Therefore, mass of 2 moles of Cl will be 71 grams. So I'll just write 71 grams of chlorine combines with. 71 grams of chlorine combines with. What is the molar mass of sulfur? 32 grams. That means mass of 1 mole of sulfur is 32 grams. So I'll just write 32 grams of sulfur. Now, how exactly you are going to read this statement? How exactly you are going to read this statement? It's pretty much simple. 71 grams of chlorine combines with 32 grams of sulfur. Therefore, 1 gram of chlorine combines with 32 divided by 71 grams of sulfur. As per definition, my dear students, 35.5 grams of chlorine would have combined with 32 divided by 71 multiplied by 35.5. The value comes out to be 16 grams of sulfur. Look at this particular term. Check exactly what we calculated. My dear students, we calculated the mass of sulfur. This is the mass of sulfur that has combined with 35.5 grams of chlorine. And as per definition, that mass of substance which combines with 35.5 grams of chlorine, what do you call that as? You call that as the equivalent mass. So this is the equivalent mass of sulfur here in the compound that is SCl2. Right? Is it clear, people? Is it clear? Let me know once in the chats if this question is clear. Let me know in the chats if this question is clear to everyone. Yeah? Perfect. So these simple questions you can solve with the help of this particular procedure, right? These are very simple, basic questions. For example, I'm giving you one more question. Let's say the question is like this. For example, I'm writing something like this. SO3 contains 32% oxygen by mass. SO3 contains 32% oxygen by mass. Calculate the equivalent mass of sulfur in SO3. Look at the question. Look at the question, guys. SO3 contains 32% oxygen by mass. Calculate its equivalent mass. Calculate the equivalent mass of sulfur. See, look carefully what exactly I'm going to do. My dear students, the compound which we have, that is SO3. The compound which we have, that is SO3. Now, as per the question is concerned, SO3 contains 32% oxygen by mass. It contains 32% oxygen by mass. What does that mean? That means 100 grams of compound. Compound is your SO3. 100 grams of SO3 contains 32 grams of oxygen. This is the meaning of this particular statement, right? SO3 contains 32% oxygen by mass. What does that mean? That means 100 grams of this particular compound. 100 grams of this particular compound contains 32 grams of oxygen. Contains 32 grams of oxygen, right? So, my dear students, I got to know 100 grams of the compound contains 32 grams of oxygen. Contains 32 grams of oxygen. Now tell me, what will be the mass of sulfur here? Total mass of the compound is 100 grams, out of which 32 grams is the mass of oxygen. Therefore, the mass of sulfur will be 100 minus 32. That comes out to be 68 grams. Okay, that comes out to be 68 grams. Now, what can we understand from this data? What did we get till now? We got to know that we had 100 grams of SO3 that contains 32 grams of oxygen. Therefore, sulfur will be 68 grams. Simple. Okay. Now, the kind of data which I got over here, I'm just going to play with this data, nothing else. I'm just going to play with this data. My dear students, I got to know that 32 grams of oxygen. I got to know that 32 grams of oxygen has combined with 68 grams of sulfur. Right? 32 grams of oxygen has combined with 68 grams of sulfur. Therefore, 1 gram of oxygen has combined with 68 divided by 32 grams of sulfur. Yes, as per the definition, 8 grams of oxygen would have combined with 68 divided by 32 multiplied by 8. The value comes out to be how much? It comes out to be 17 grams of sulfur. Now, look at this particular term and check what did we calculate exactly. If you look carefully, this is the mass of sulfur. This is the mass of sulfur that has combined with 8 grams of oxygen. And as per definition, that mass of sulfur which would have combined with 8 grams of oxygen, that mass of sulfur which would have combined with 8 grams of oxygen, what do I call that as? I'll be calling that as equivalent mass. So this is nothing but equivalent mass of sulfur here. I believe I'm clear. I believe I'm clear till here, right? Let me give you one more question. The question is, for example, like this. 0.84 grams of metal hydride. 0.84 grams of metal hydride contains 0.04 grams of hydrogen. Contains 0.04 grams of hydrogen. Calculate the equivalent mass of the metal. Calculate the equivalent mass of the metal. How exactly you are going to solve this? It's again the similar type of question. My dear students, as per the question is concerned, you have got a metal hydride. Let's say the formula of the metal hydride is MXHY. This is your metal hydride. This is, for example, your metal hydride. As per the question, we have got 0.84 grams of the metal hydride. Now, 0.84 grams of the metal hydride contains what? It contains 0.04 grams of hydrogen. If 0.84 grams of metal hydride contains 0.04 grams of hydrogen, what will be the mass of the metal here? It will be 0.84 minus 0.04. It comes out to be nothing but 0.80 grams. It comes out to be It comes out to be 0.80 grams. Now look carefully. Look at the data. I'm going to play with this data, nothing else. I got to know, people, I got to know 0.04 grams of hydrogen. 0.04 grams of hydrogen has combined with 0.80 grams of metal, right? 0.04 grams of hydrogen has combined with 0.80 grams of metal. Therefore, I can say 1 gram of hydrogen would have combined with 1 gram of hydrogen would have combined with 0.80 divided by 0.04 grams of metal, which comes out to be how much? It comes out to be nothing but 20 grams. So look at this particular term. What is this particular term? If you look carefully, this is the mass of metal. This is the mass of metal that has combined with 1 gram of hydrogen. And as per definition, that mass of substance which combines with 1 gram hydrogen, what do you call that as? You call that as the equivalent mass of metal. So equivalent mass of metal here is nothing but 20 grams. Okay? I believe I'm clear till here. I believe I'm clear till here. Yeah? Right, people? For example, I'm giving you one more simple question. Let me see if you can solve this or not. Let's say the question is like this. 74 grams of metal chloride. 74.5 grams of metal chloride contains 35.5 grams of chlorine. Contains 35.5 grams of chlorine. The question is saying, calculate the equivalent mass of the metal. Will you be able to solve this question, people, on your own? You need not to do any sort of calculation here in this question. It's already done and dusted. The question is already done and dusted. The question is saying we have got a metallic chloride like this. This is the metallic chloride. What is the mass of the entire metallic chloride? If you look carefully, the mass of the entire metallic chloride is nothing but 74.5 grams. Now, as per the question, 74.5 grams of the metallic chloride, it contains what? It contains 35.5 grams of chlorine. If 74.5 grams of metallic chloride contains 35.5 grams of chlorine, so what will be the mass of metal here? This minus this. The value comes out to be 39 grams. Look carefully. Look carefully. What did we calculate here? Can I say 35.5 grams of chlorine has combined with 39 grams of metal? This is something which I got to know. 35.5 grams of chlorine has combined with 39 grams of metal. And that mass of substance which combines with 35.5 grams of chlorine, what do I call that as? I call that as equivalent mass. So equivalent mass of metal here directly is nothing but 39 grams. So this is the mass of metal that has combined with 35.5 grams of chlorine. And as per definition, that mass of substance which would have combined with 35.5 grams of chlorine, I will be calling that as equivalent mass of the substance. So equivalent mass of the metal here is nothing but 39 grams. If I'm clear till here, let me know once in the chats. Then I'll move ahead. These are the basic questions which can be asked when it comes to the term equivalent mass. These are the questions which are based on the definition. Now, I am going to get into the details of equivalent mass. But before that, let me know once in the chats quickly. Let me know once in the chats quickly if all the things are clear till here. Quickly, people. Everyone in the chats. I'm looking at your chats. Perfect. Now, guys, let's get more into the details. Okay? Have a proper eye on the things which I'm going to tell you now. Right? Just give me a second. Yeah. See, guys. Over here, I'm going to write a result which you guys will be remembering from now onwards. And the result is like this. I'm writing equivalent mass of the substance. Equivalent mass of the substance is always equal to, it is always equal to the molar mass of the substance. Molar mass of the substance divided by the n factor of the substance. or you can call it as the valency factor as well. Well, this is one direct result. This is one direct formula which will be used to calculate equivalent mass of any substance, people. This one direct formula, this one direct result, with the help of which we can calculate equivalent mass of any substance. Equivalent mass of the substance is always equal to the molar mass of the substance divided by the n factor of the substance. N factor is also what you call as the valency factor. Now, what this n factor is all about, what this valency factor is all about, let's get to know about the n factor in detail. Let's get to know about our n factor in detail. Okay, so have an eye properly over here, because this is going to be something which is very, very, very important. My dear students, the first case which I'm going to share with you, what is that? That is n factor of an element. N factor of an element. My dear students, remember, n factor of an element is nothing but the valency of the element. Whatever is going to be the valency of the element, that is something which you will be calling as n factor of the element. Whatever is going to be the valency of the element, that's what you'll be calling as n factor of the element. And once you get n factor of the element, you can easily calculate equivalent mass. How? Molar mass divided by n factor. Molar mass divided by n factor. For example, let's say I'm taking few elements over here. Let's say I'm taking nitrogen. Let's say I'm taking oxygen. Let's say I'm taking sodium. Let's say I'm taking magnesium. These are different elements which I've taken over here. Now, if I ask you, what is the valency of nitrogen? You will say valency of nitrogen is 3. What is the valency of oxygen? It's 2. What is the valency of sodium? It's 1. What is the valency of magnesium? It's 2. My dear students, since you got to know the valency of these elements, and let me tell you, valency of an element is basically the n factor of the element, right? It is basically the n factor of the element. So you technically got the n factor of all these elements which I mentioned over here, right? Okay, so this 3 I'll be calling as n factor of nitrogen. This 2 I'll be calling as n factor of oxygen. This 1 I'll be calling as n factor of sodium. This 2 I'll be calling as the n factor of magnesium. Since you got their n factors, you can easily calculate their equivalent masses. For example, I want to calculate equivalent mass of nitrogen. Equivalent mass of nitrogen. Equivalent mass is nothing but molar mass by n factor. What is the molar mass of nitrogen? That's 14 grams divided by. What is the n factor of nitrogen? That's 3. So 14 by 3 grams is the equivalent mass of nitrogen. If I ask you, what is the equivalent mass of oxygen? You can easily calculate it. Molar mass of oxygen divided by the n factor of oxygen, right? Equivalent mass of sodium will be equal to molar mass of sodium divided by n factor of sodium. Similarly, equivalent mass of magnesium will be nothing but, as per the formula, it's going to be molar mass of magnesium divided by n factor of magnesium. That's all, right? So remember this first term from now onwards. Equivalent mass can be calculated with the help of a direct result. Equivalent mass is nothing but molar mass divided by n factor. Now, n factor of an element is basically the valency of an element. N factor of an element is basically the valency of an element. Whatever is the valency of an element, that's what you will be calling as n factor. Once you get the n factor, you can easily get the equivalent mass. How? Molar mass divided by n factor. Okay, this was case number 1. Now, we have got almost 9 to 10 cases over here, which we have to discuss in detail. 9 to 10 cases, people. The second case, what is that? That is your n factor of an ion. N factor of an ion. N factor of an ion is nothing but, it is equal to magnitude of charge present on the ion. N factor of the ion is nothing but, it is the magnitude of charge present on the ion. For example, let me take certain ions over here. Let's say we have got Na positive. Let's say we have got Cl negative. Let's say we have got SO4 dinegative. Let's say we have got PO4 trinegative. These are different ions which I have taken over here, right? Now, people, what is the charge on sodium? It's +1. Just talk about the magnitude. Magnitude of charge here is 1. Magnitude of charge here is also 1. Magnitude of charge here is 2. Magnitude of charge here is 3. And magnitude of charge present on an ion. That gives me what? That gives me the n factor of an ion. So this is technically the n factor of Na positive. This is your n factor of Cl negative. This is the n factor of your SO4 dinegative. And this is the n factor of the last one. Well, if you got these n factors, you can easily calculate their equivalent masses. How exactly? For example, I'm writing equivalent mass of Na positive. It's going to be equal to molar mass of Na positive divided by n factor. right? Now you must be thinking about what is going to be the molar mass of Na positive. My dear students, by the presence of charge, nothing happens to molar mass. Whatever is the molar mass of sodium, same is going to be the molar mass of Na positive. Whatever is the molar mass of chlorine, same is the molar mass of Cl negative. So by the presence of charge, nothing happens to molar mass. Okay, so equivalent mass of Na positive will be equal to molar mass of sodium divided by the N factor, that's 1. Equivalent mass of Cl negative will be nothing but molar mass of Cl negative divided by its N factor, that's 1. Equivalent mass of SO4 dinegative here will be, it will be molar mass of SO4, which will be, this is 64 plus 32, 96 divided by 2, and it's going to be grams, right? Similarly, equivalent mass of PO4 trinegative will be equal to molar mass of PO4, that's 95 divided by its N factor, that's 3. So this is our second case of the N factor calculation. Okay, this is the second case of our N factor calculation. So this was N factor of an ion. The third one, guys. Let me talk about the N factor of a salt. N factor of a salt. Let me tell you, N factor of a salt is nothing but, it is equal to the LCM of charge on cation, comma, the charge on anion. LCM of charge on cation, comma, the charge on anion. You can remember it like this. For example, you can tell me any salts in the chats. Give me any salts, some common salts, which you already know. See guys, for example, I'm talking about NaCl, a very, very, very common salt, right? Right, people? So NaCl, the first salt. Let's say you have got CaCl2. Okay. Let's say you have got AlCl3. Right? Let's say you have got Al2SO4 whole thrice. These are some salts which I have taken. Now, my dear students, what about their N factors? What about their N factors? I don't understand. N factor of a salt is nothing but LCM of charge on cation, comma, charge on anion. So first of all, you need to know what is the charge on cation, what is the charge on anion. What is the charge on cation, what is the charge on anion. Cation, anion, cation, anion, right? Now, how do you get the charges? Yes, you have got one sodium here, one chlorine here. Just crisscross these. This one becomes the charge here, this one becomes the charge here, right? This 2 becomes the charge here, this 1 becomes the charge here. Now, this 3 becomes the charge here, this 1 is going to be the charge here. This 3 will be the charge here, this 2 will be the charge here. So you got the charges on cations and anions. You got the charges on cations and anions, right? Now, LCM of charge on cation and anion. LCM of this 1 and 1. LCM of 1 and 1 comes out to be 1 only. LCM of 2 and 1 comes out to be 2. LCM of 3 and 1 comes out to be 3. LCM of 3 and 2 comes out to be 6. LCM of the charge on cation and anion. That gives me what? That gives me the N factor of the salt. So I got the N factors of different salts. If you got the N factors of different salts, you can easily calculate their equivalent masses. For example, let's say I need to calculate equivalent mass of NaCl. How exactly you are going to do it? Molar mass of NaCl, which is 58.5 grams, divided by its N factor. That's 1. So this will be the equivalent mass of NaCl. And similarly, you can calculate the equivalent mass of all the other salts as well. Okay, I believe I'm clear till here, right? This was my third category, that was N factor of the salt, which is always equal to LCM of charge on cation, comma, the charge on anion. Now moving ahead, that is the fourth category. This is important. What is that? It is going to be N factor of an acid. N factor of an acid. How do you exactly define N factor of an acid? My dear students, N factor of an acid is defined as, the basicity of the acid. It is defined as the basicity of the acid. Now, how do we exactly define the basicity of the acid? Basicity of the acid is defined in number of ways. Basicity of the acid is defined in number of ways. Number one, number of H positives An acid donates. Number of H positives an acid donates. Or number of OH negatives an acid accepts. Number of OH negatives an acid accepts. Number of H positives an acid donates, or number of OH negatives an acid accepts, right? Or you can say number of lone pairs an acid accepts. This can be one more. This can be one more way of defining the basicity of the acid, right? Now, my dear students, what exactly is meant by all of this? Try to understand. I'm starting from exact basic part. For example, I'm taking certain acids. Let's say HCl. Let's say you've got H2SO4. Let's say you've got HNO3. Let's say you've got H3PO4. These are some common acids which you have heard till now, right? Okay. For example, I want to calculate their equivalent masses. In order to get their equivalent masses, what do I need? I need their N factors. Now, my dear students, imagine you are introducing this HCl into water. Now tell me one thing. When you introduce HCl into water, how many H positives it's going to donate? It will donate 1 H positive. This H2SO4 in water is going to donate 2 H positives. HNO3 is going to donate 1 H positive. H3PO4 is going to donate 3 H positives. And let me tell you, the number of H positives an acid donates, that defines the basicity of the acid. And whatever is the basicity of the acid, that's something which you call as the N factor of the acid. So N factor of HCl is nothing but 1. N factor of H2SO4 here is 2. N factor of HNO3 here is 1. N factor of H3PO4 here is 3. Well, people, if you got the N factors of these acids, you can easily calculate their equivalent masses. How exactly? Molar mass of the acid divided by N factor. Molar mass divided by its N factor. Molar mass divided by its N factor. You'll be easily getting the equivalent mass of these acids, right? Now, here is one point. Let me see what exactly will be your answer. My dear students, for example, I'm writing certain acids here. For example, H3PO2. Let's say you've got H3PO3. Let's say you've got H3PO4. Let's say you've got H3PO5. Can you let me know what do you think will be the N factor of this acid, H3PO2? Normally, you will say it is 3. It will donate 3 H positives. This will donate 3 H positives. This will donate 3 H positives. This will donate 3 H positives. So N factor of all of these acids should be 3. But that's not the case. As a common man, right? As a layman, you will say, since H3PO2, it has got 3 hydrogens, so it's going to donate 3 H positives. This is also going to donate 3 H positives. All of them are going to donate 3 H positives. So their N factors should be what? Their N factors should be 3. But that's not the case. Why is that? Let me mark a note over here. And I would want you guys to take a note of this statement as well. Let me tell you, an acid donates only that hydrogen in the form of H positive. An acid donates only that hydrogen in the form of H positive, which is attached to more electronegative element. Like what? More electronegative element like fluorine, oxygen, nitrogen, etc. And acid will be only donating only that H positive. Acid will be donating only that hydrogen in the form of H positive, which will be attached to what? Which will be attached to more electronegative element. Like what? Like fluorine, oxygen, nitrogen. Now, have a look over here. If you talk about the structure of your H3PO2, my dear students, I hope you guys remember, I have given you the structure of all of these. This is your H3PO2. Structure of your H3PO3. Structure of your H3PO3. This is the structure of your H3PO3. Okay. Similarly, structure of your H3PO4. This is the structure of your H3PO4. I hope you remember in the last session we have discussed this. Okay. H3PO5. This is the structure of your H3PO5. I have drawn all these structures again. Now tell me one thing. How many How many hydrogens are there in H3PO2? There are 3 hydrogens. Out of these 3 hydrogens, how many hydrogens are attached to more electronegative element like oxygen? I would say only 1 hydrogen is attached with oxygen. In the second case, 2 hydrogens are attached with more electronegative element like oxygen. Over here, 3 hydrogens are attached with more electronegative element like oxygen. Over here, again 3 hydrogens are attached with more electronegative element like oxygen. And I told you long back, an acid donates only that hydrogen in the form of H positive, which is attached to what? Which is attached to more electronegative element like oxygen. So if I ask you how many hydrogens this is going to donate in the form of H positive, I'll say 1 H positive is going to donate. This one, 2 H positives. This one, 3 H positives. This one, 3 H positives. And the number of H positives an acid donates, the number of H positives an acid donates, that defines its basicity. And whatever is the basicity of the acid, what do you call that as? You'll be calling that as N factor of the acid. So N factor of H3PO2, here is 1, here it's 2, here it's 3, here it's 4. If you got the N factors of these acids, you can easily calculate their equivalent masses. How exactly? Molar mass divided by N factor. Molar mass divided by N factor. Molar mass divided by N factor. That's it. Yeah? Now guys, one more thing which I would want to let you know about these acids. It is a special case. It is a special case. Boric acid. Have you heard about boric acid? Have you heard about boric acid? Its formula is what? H3BO3. Or sometimes just to confuse you, we'll write it like this. BOH whole thrice. Just to confuse you. So that you interpret it as a base, but it's not a base. It's basically H3BO3 only. It's boric acid only. It's a special case, this boric acid. My dear students, talking about this particular boric acid, let me tell you, this boric acid, it's a weak Lewis acid. It is a weak Lewis acid. It's a weak Lewis acid. Now, understand few things about this boric acid. If you talk about the structure of the boric acid, it's like this. B, OH, OH, and OH. This is the structure of your boric acid. Now, my dear students, if I introduce this boric acid into water, what is going to happen? If I introduce this boric acid into water, what's going to happen? Normally, you'll think like this. Normally, you'll tell me that there are 3 hydrogen atoms, and all these 3 hydrogen atoms are attached to more electronegative element like oxygen. So, this boric acid is going to donate all the 3 hydrogens in the form of H positive, because all the 3 hydrogens here are attached to more electronegative element like oxygen. So it should donate all the 3 hydrogens in the form of H positive. So its N factor should be 3. That's something which you will answer. Its N factor should be 3. But its N factor is not 3. Its N factor is 1. Why is that? Why is that? Why is the N factor of boric acid here is 1? Try to understand, people. See, let me show you the exact scenario. First of all, if you look at this boron, how many bonds it's forming? 1, 2, 3. It's forming 3 bonds. So can I say in the outermost shell of boron, there are right now 6 electrons? How many should have been? There should have been 8 electrons. With boron in the outermost shell of boron. But right now, how many are there? There are just 6. There are just 6 electrons in the outermost shell of boron. But it should have 8 electrons in the outermost shell. So tell me, whether this boron right now, is it electron deficient or electron rich? I would say this boron center over here, it is electron deficient. If this boron center is electron deficient, if by chance, if this boron center is electron deficient center, if by chance it gets some electrons, will it accept them? Yes, it's going to accept them because it's electron deficient. It needs electrons. If by chance it gets electrons from somewhere, it is going to accept them. Now, my dear students, what exactly are we doing? We are introducing this boric acid into water. When we introduce this boric acid into water, water has got oxygen. And this oxygen has got a lone pair. This oxygen has got 2 lone pairs. Now, what this oxygen exactly does, this oxygen is going to donate one of the lone pair towards boron in the form of a coordinate bond. In the form of a coordinate bond. This oxygen is the donor atom which carries the positive charge, and this is the acceptor atom which carries the negative charge. Okay. Now after this, what is going to happen? Earlier, oxygen did not have any charge. Now oxygen got the positive charge. Let me tell you, positive charge on an electronegative element. Positive charge on an electronegative element makes it highly unstable. Now this oxygen is highly unstable. It got positive charge, right? Positive charge on an electronegative element makes it unstable. So I would say it would want to be stable again. How it will be stable again? When this positive charge gets cancelled, when this positive charge is nullified, when this positive charge is compensated. How this positive charge is compensated? I would say one of the OH bond, there are two OH bonds. One of the OH bond will break towards oxygen and one of the hydrogen will leave as H positive. One of the hydrogen will leave as H positive. So what do we get at the end? At the end we got, or let me write it again. So initially we took the boric acid, BOH whole thrice. We introduced this boric acid into water, right? Now I would say the OH part of water gets attached to boric acid and one hydrogen leaves as H positive, right? So initially there were 3 OHs. Now one OH, it is accepting from water and it's going to get converted into BOH4 negative and with that H positive. This is the entire scenario which I wrote in a single statement. Now tell me one thing. How many OHs were there? There were 3 OHs in the beginning. Now when you introduce this boric acid into water, how many OHs are there? Initially it had 3 OHs, now it has 4 OHs. So what has happened? Can I say this boric acid, it has accepted one OH negative? Yes, this boric acid, it has accepted one OH negative. And the number of OH negatives, that an acid accepts, that defines the basicity of the acid. And whatever is the basicity of the acid, that's something which I'll be calling as N factor of the acid. So N factor of this boric acid, it looks like 3, but it's not 3, it is 1. It is 1. Got it? Yes? Okay, one more question I would want to ask you. What about this H positive? Is this H positive of boric acid? No, this is not the H positive of boric acid. This is the H positive of water. This is the H positive which you got from water, right? This is the H positive which you got from water. This is not the H positive of boric acid, right? Let me tell you, this boric acid, it is not the protic acid. It does not give its own H positive, right? It behaves like a Lewis acid. It behaves like a Lewis acid, and Lewis acids are the ones which accept pair of electrons. That's what this boric acid did. It accepted a pair of electron from oxygen. It accepted a pair of electron from oxygen. I believe I'm clear. Now guys, one more thing I would want to discuss about the acids. And what is that? Let me write it over here. About the acids only. Let me write N factor of an acid. N factor of an acid changes on changing. N factor of an acid changes on changing the type of the reaction. N factor of an acid changes on changing the type of the reaction. What exactly it means? Have a look, guys. Over here, I'm going to take 2 reactions. Take 2 reactions. One is your H2SO4 plus NaOH. Let's say it gives NaHSO4. With that, I'm writing water. The second reaction which I'm taking, for example, that's like this. H2SO4 plus 2 times NaOH. Let's say it gives Na2SO4 plus 2 times H2O. These are the 2 reactions which I've taken over here. Just a second, guys. Atomic structure chapter, that's not stopped. Okay? Atomic structure is not stopped. It just requires one more lecture, which I'll be posting in coming days, right? In the recorded format. That lecture will be just for like 2 hours. With that, you'll complete that chapter. Okay, understand now. Over here, my dear students, I've taken 2 reactions, okay? Now look carefully what exactly I'm going to say. First of all, there is something which I believe all of you would be already knowing. What is that? That's simple like this. You know, when one H positive and one OH negative, when they are going to interact, they will lead to the formation of one water molecule, right? One H positive and one OH negative interacts to form one water molecule. Similarly, if I ask you, what about two H positives? I would say two H positives will interact with two OH negatives and they will lead to the formation of two water molecules, correct? Now, if you look at these two reactions carefully, my dear students, how many water molecules are being formed here? One water molecule. How many water molecules are being formed here? Two water molecules. Can I say for the formation of one water molecule, can I say this acid would have given one H positive, this base would have given one OH negative, and these two would have interacted and they would have led to the formation of one water molecule? Yes, I can say that. Similarly, in the second reaction, two molecules of water are being formed. So for the formation of two water molecules, can I say this acid would have given two H positives and this base would have given two OH negatives? They would have interacted and they would have led to the formation of two water molecules. Yes? Simple. Now tell me, how many H positives this acid is donating here? It is donating one H positive. The number of H positives an acid donates, that defines its basicity. And whatever is the basicity of the acid, that's something which you call as N factor of the acid. So N factor of H2SO4 in this reaction is 1. If I ask you, how many H positives this particular acid is donating over here? This acid is donating 2 H positives. And the number of H positives an acid donates, that defines its basicity, right? And whatever is the basicity of the acid, that's something which you call as N factor, right? So in the first reaction, N factor of H2SO4 is 1. In the second reaction, N factor of H2SO4 is 2. Now tell me one thing. What will be the equivalent mass of H2SO4 here? It will be equal to molar mass of H2SO4 divided by 1. What is the equivalent mass of H2SO4 here? It will be molar mass of H2SO4 divided by 2. So if I ask you whether you are getting the same equivalent mass for H2SO4 in both the reactions, no. No, right? In the first reaction, equivalent mass of H2SO4 is equal to molar mass by 1. In the second one, it's molar mass divided by 2, right? So, equivalent mass of same substance is coming out to be different. Equivalent mass of same substance is coming out to be what? It's coming out to be different, right? So, I'm generalizing a statement over here. And the statement is very simple. Statement is equivalent mass is a variable quantity. It is a variable quantity. Unlike what? Unlike molar mass. Unlike molar mass, which is always fixed. Unlike molar mass, which is always fixed. I believe all these things are absolutely clear to you till now. So this was about the N factor of acids. Right? Okay. Now, talking about the fifth category. Let's go into the fifth category of N factors. Fifth category of N factors. What is that? That is your N factor of base. N factor of a base. How do you exactly define the N factor of the base? The way we define the N factor of the acid, in the similar way, you guys are going to define the N factor of a base. Okay? Try to understand, people. N factor of a base is nothing but it is defined as the acidity of the base. It is defined as the acidity of the base. Now, how do you exactly define the acidity? Acidity is defined as number of OH negatives a base donates. Number of OH negatives a base donates. Number 2, number of H positives a base accepts. Number 3, you can say it like this as well. Number of lone pairs a base donates. So how do we exactly define the n factor of the base? N factor of the base is nothing but acidity of the base. And how many ways do we have to define the acidity of the base? There are 3 ways by means of which I can define the acidity of the base. Number 1, number of OH negatives a base donates. Number of H positives a base accepts. Number of lone pairs a base donates, right? For example, people, let's say I'm starting with NaOH. This is something which every one of you would be knowing. Let's say I've got KOH. Let's say I've got calcium hydroxide, CaOH whole twice, right? Let's say I've got zinc hydroxide. These are the very common bases which we have, right? Now, my dear students, think logically. If you introduce NaOH into water, how many OH negatives it's going to donate? It will donate 1 OH negative because it has got only one. This particular species, it is also going to donate 1 OH negative. This particular species will be donating 2 OH negatives. This particular species will be donating 2 OH negatives into water, right? And we know the number of OH negatives, a base donates. The number of OH negatives a base donates, that defines the acidity of the base. And let me tell you, whatever is going to be the acidity of the base, that's something which you call as n factor of the base. So what is the n factor of NaOH here? N factor of NaOH is 1. N factor of KOH is 1. N factor of calcium hydroxide is 1. N factor of zinc hydroxide is 1. If you got the n factors of these bases, you can easily calculate their equivalent masses. How? Molar mass divided by n factor, molar mass divided by n factor, molar mass divided by n factor, and so on. Yeah? Now guys, there is one more thing which I would want to share with you. What is that? For example, if you have got a base like this, NH3. If you have got a base like this, NH3. Now, for example, you are introducing this base into water, right? You're introducing it into water. What is it forming? It's forming NH4 positive plus OH negative. You got NH4 positive plus OH negative. This is the reaction that's given to me. Let's say this is the reaction that's given to me. And I'm asking you to calculate the n factor of this NH3. How exactly you guys are going to calculate the n factor of NH3? My dear students, if you look carefully, look very carefully. How many hydrogens were here? 3. How many hydrogens were here? 3. Okay. Now, when you introduce this NH3 into water, it got converted into what? It got converted into NH4 positive. So how many hydrogens are here now? 4. Initially, it had 3. Now, when you introduce this into water, now it has how many? It has 4. It has 4. So what has happened? So when you have introduced this NH3 into water, I would say this NH3, it has accepted 1H positive. This NH3, it has accepted 1H positive and got converted into NH4 positive. And we know the number of H positives a base accepts, that also defines the acidity of the base. And whatever is the acidity of the base, that's something which you call as n factor of the base. Right? So my dear students, if I ask you now, what is the n factor of this NH3? You'll say n factor of NH3 here is 1. Why is that? Because this NH3 in water, it is accepting 1H positive. And number of H positives accepted by a base, that defines its n factor. That defines its acidity. Right? Rahul, H3BO3, boric acid. Its name is only boric acid. It is acid. Okay? Perfect. I believe these sort of things, these sort of questions you can easily solve, right? Now, my dear students, there is one more question which I'm giving you. For example, let's say I've got 2 reactions like this. I would want you to let me know about their n factors. Okay, for example, I'm writing a reaction. The reaction is like this. Zinc hydroxide plus HCl. Let's say it gives ZnOHCl plus H2O. This is one of the reaction which I wrote. The second reaction which I'm writing over here, let's say that is like this. Zinc hydroxide plus 2 times HCl gives ZnCl2 plus 2 times water. These are the 2 reactions which I have. Now, people, I'm asking you one thing. What is the n factor of the zinc hydroxide here? And what is the n factor of the zinc hydroxide here? See, I already gave you the concept a few minutes back. If you remember that, then you would be in a position to answer me this question. Understand, guys? In the first reaction, 1 water molecule is being formed. In the second reaction, 2 water molecules are being formed. Now, for the formation of 1 water molecule, I would say this acid would have given 1H positive. This base would have given 1 OH negative. and this one H positive and one OH negative, they would have interacted and formed one water molecule. Similarly, in the second case, two water molecules are being formed. So for the formation of two water molecules, this acid would have given two H positives, this base would have given two OH negatives, and then these two would have interacted and formed two water molecules. Now tell me one simple thing. How many OH negatives this base is donating over here? It is donating one OH negative. How many OH negatives this base is donating over here? It is donating two OH negatives. And the number of OH negatives a base donates. Number of OH negatives a base donates. That defines its acidity. And whatever is the acidity of the base, that is something which you call as the N factor of the base. So my dear students, what is the N factor of this zinc hydroxide here? It is 1. What is the N factor of this zinc hydroxide here? It's 2, right? So what will be the equivalent mass of zinc hydroxide here? Molar mass divided by 1. In the second case, it is molar mass divided by 2. So again you are saying, my dear students, equivalent mass of zinc hydroxide in both the reactions is coming out to be different, which is again telling you equivalent mass is not a fixed quantity. It's a variable quantity. It is a variable quantity, right? Unlike your molar mass, which is always fixed. I believe I'm clear till here. So this was my fifth case of the N factor calculation. The sixth case. What is my sixth case? That is N factor of oxidizing agents and reducing agents. How do we exactly calculate the N factor of oxidizing and reducing agents? Try to understand carefully, guys, what I'm going to say now, because now it's going to be super important. Okay? Now it's going to be super important. But before showing you this, let me know once in the chats whether all the things which I have discussed till now are clear to everyone or not. Quickly. Quickly, guys, in the chats. Yeah? When will the class end? The class will end in 1 hour. Yes, I'll also teach class 12 chapters. You don't worry. Everything I'll be discussing. All right, so let's move on. Let's start with the N factor of oxidizing and reducing agents. I hope you exactly remember what oxidizing agents are, what reducing agents are. Let me write the definition first, then I'll make you understand one by one. See guys, N factor of oxidizing reducing agent is always equal to the number of moles of electrons lost, gained, exchanged. Lost, gained, exchanged by by 1 mole substance. The number of moles of electrons lost, gained, or exchanged by 1 mole substance. Now see guys, try to understand properly what exactly I'm going to say. I'm talking about the N factor of oxidizing reducing agent. It's always equal to the number of moles of electrons lost, gained, or exchanged by 1 mole of substance. What exactly it means? Have a look. For example, I've got the reaction like this. A plus B. For example, it gives A positive plus B negative. This is the reaction. A plus B gives A positive plus B negative. Now, you will tell me one thing. If I ask you what is the oxidation state of A over here, you'll say 0. What is the oxidation state of B over here? 0. What is the oxidation state of A over here? It's plus 1. What is the oxidation state of B over here? It's minus 1. Okay. If you look carefully, what is happening to the oxidation state of A? 0 to plus 1 means increase. Oxidation state of A is increasing during the process. And you should know, increase in the oxidation state is something which we call as oxidation. The one that undergoes oxidation, that loses electrons. that loses electrons. So A will be losing electrons here. And the one that undergoes oxidation, what do we call that as? I hope you remember. That's called as a reducing agent. Yeah, that's called as a reducing agent. Similarly, my dear students, have a look. 0 to minus 1. 0 to minus 1. What is happening? 0 to minus 1. During this process, oxidation state is decreasing. 0 to minus 1. Decrease in the oxidation state is something which you call as a reduction. Decrease in the oxidation state is what you call as a reduction. And my dear students, a reduction involves what? It involves the gain of electrons, right? And the one that undergoes a reduction, that is something which you call as the oxidizing agent. So first of all, you identified your oxidizing agent and the reducing agent, right? You identified the oxidizing agent and the reducing agent. Now, since you identified the oxidizing and reducing agent, you got to know which substance among these two is gaining electrons and which substance among these two is losing electrons. Now it is the high time to calculate the n factors of this A and B over here. For example, you have to calculate n factor of A. You have to calculate n factor of A. What is A doing? A is undergoing oxidation. A is losing electrons. I want to calculate n factor of A. I want to calculate n factor of A. That means technically I want to calculate the number of moles of electrons lost by 1 mole of A. I want to calculate n factor of A. So technically I want to calculate the number of moles of electrons. The number of moles of electrons lost by 1 mole of A. Similarly, in order to calculate the n factor of B, what B exactly does? B undergoes a reduction. B gains electrons. Now I want to calculate an n factor of B. I want to calculate n factor of B. That means technically, what exactly do I want to do? What exactly do I want to calculate? As per the definition, I want to calculate the number of moles of electrons. The number of moles of electrons gained by 1 mole of B. Gained by 1 mole of B. Now, how exactly you guys are going to calculate these things? How exactly you are going to get to know the n factor of A and n factor of B? There's a simple process for that. Just follow the process. N factor of A is equal to n factor of A is equal to. What is the initial oxidation state of A? That's 0. What is the final oxidation state of A? That's plus 1. Just do one thing. Mod of change in the oxidation state of A. Change in the oxidation state of A means final oxidation state of A, that's plus 1, minus the initial oxidation state of A, that's 0. The value comes out to be 1. But this one, it is the change in the oxidation state for 1 atom of A. And over here, I've got only 1 atom of A. So I'm just multiplying it with 1 at the end. The value comes out to be 1. So I got to know that n factor of A here is 1. Did you understand the process? Did you understand the process, people here? Similarly, for example, I need to calculate the n factor of B. How exactly am I going to calculate the n factor of B? 0 to minus 1. 0 to minus 1. Calculate the change in the oxidation state of B, which is final oxidation state of B minus initial. Final is minus 1. Initial is 0. The value comes out to be 1. This 1 is the change in the oxidation state for 1 atom of B. But over here, I've got only 1 atom. So multiplied with the number of atoms. Multiplied with the subscript of B. The value comes out to be 1. So this one I'll be calling as n factor of B over here. I believe I'm clear with this. I believe I'm clear with this. Yes? Right? Perfect. Let me take one more similar example, then I'll give you the actual examples, right? These are the general examples which I'm giving you right now. Okay? For example, you have got the reaction like this. A2 plus B2. Let's say it gives 2 times A positive plus 2 times B negative. Let's say this is your reaction. Okay? Let's assume this is your reaction. Now try to understand. Let's assume this A and B right now, they are present in their standard states. If they're present in their standard state, their oxidation states are supposed to be 0. So what are the oxidation state of A here? It's plus 1. Oxidation state of B here, it's minus 1. Now tell me one thing. 0 to plus 1. 0 to plus 1. Increase in the oxidation state. Increase in the oxidation state is what you call as oxidation. So this A2 is undergoing oxidation here. If A2 is undergoing oxidation, it's your reducing agent. Similarly, 0 to minus 1, decrease in the oxidation state. Decrease in the oxidation state is something which you call as a reduction, and the one that undergoes a reduction is your oxidizing agent. So this is your oxidizing agent here. Now, what do we need to calculate? We need to calculate n factor of A2 and B2. Now, people try to understand. N factor of A2 will be equal to, what is the change in the oxidation state of this A? 0 to +1. This is initial, this is final. So mod of final minus initial. The value comes out to be 1. This 1 is the change in the oxidation state for one atom of A. But here I've got two atoms. So multiplied by subscript. The value comes out to be 2. So this 2 is basically the n factor of A2 over here. Right? Similarly, what about the n factor of B2? What about the n factor of B2? See, 0 to -1. Calculate the change. Final minus initial. The value comes out to be 1. 1 is the change for one atom, but here I've got 2. So multiplied it with 2, the value comes out to be 2. So 2 is the n factor of B2 as well. Now people, if I ask you, what is the n factor of A positive? What is the n factor of this A positive? Now, in order to calculate the n factor of A positive, right, you'll be considering this as the initial oxidation state of A. You'll be considering this as the final oxidation state of A. Now, this is the initial one. This is the final one. Get the change. Change is going to be final, that is 0, minus initial, that's +1. The value comes out to be 1. 1 is the change for one atom of A. And over here, the subscript is 1. So multiplied it with 1. The value comes out to be 1 only. So n factor of A positive here comes out to be 1 only. N factor of A positive here comes out to be 1 only. Now, similarly, if I ask you, what is the n factor of B negative? What is the n factor of B negative? Get the change in the oxidation state. N factor of B negative, right? This is something which I'll be calling as initial. And this I'll be calling as final. So final minus initial ka mod. Final is 0. Initial is 1. Mod of it is going to be 1. This 1 is the change in the oxidation state for one atom of B. And over here, the subscript is 1 only. So I'm multiplying it with 1. The value comes out to be 1 only. So you got the n factor of all these species over here. You got the n factors of all these species over here. I hope I'm clear with this. I hope I am clear with this. Okay? Perfect, people? All clear? All clear? Remember, the one whose n factor is to be calculated, you have to look at its subscript. For example, here I was supposed to calculate n factor of A2. Right? The one whose n factor is to be calculated, look at its subscript. Right? Do not see the subscript of the one to which it's converted into. Do not see that. For example, here I was supposed to calculate n factor of A positive. So I looked at the subscript of A positive only. I did not look at the subscript of something to which it's getting converted. No. I looked at the subscript of A positive only. Be careful with this. Okay? Let me give you certain questions so that you'll understand this. Or, before giving you the questions, if I talk about KMnO4, I hope you would have heard about KMnO4. What is KMnO4? It's a very strong oxidizing agent. It's a strong oxidizing agent, KMnO4, right? People, it's a strong oxidizing agent. And this KMnO4, in different reactions, in different mediums, it shows different reactions. What exactly that means? Let me tell you that. This KMnO4, let me tell you, in acidic medium, KMnO4 gets converted into Mn dipositive. In which medium? In acidic medium. In acidic medium, KMnO4 gets converted into Mn dipositive. Similarly, in neutral or slightly alkaline medium. In neutral or slightly alkaline medium, this KMnO4, it gets converted into MnO2. And my dear students, remember, in your strongly alkaline medium, this KMnO4, it gets converted into MnO4 dinegative. These are the three things which you have to remember. KMnO4 in acidic medium gets converted into Mn dipositive. In neutral medium, it gets converted into MnO2. In strongly alkaline medium, it gets converted into MnO4 dinegative. Now, my dear students, look carefully. If you ask me what is the oxidation state of manganese here, I'll say +7. Oxidation state of manganese here, +2. +7 to +2. Decrease in the oxidation state. Decrease in the oxidation state is what you call as a reduction. Decrease in the oxidation state is what you call as a reduction. The one that undergoes reduction, that's the oxidizing agent. So KMnO4 here, it behaves like the oxidizing agent, right? Similarly, in the neutral medium also, oxidation state of manganese here is +4, right? +7 to +4, decrease. Decrease means reduction, oxidizing agent. Similarly, here it is +6, +7 to +6, decrease in the oxidation state, reduction. The one that undergoes reduction, that's the oxidizing agent. So in all the three mediums, your KMnO4, it behaves like what? Your KMnO4 behaves like the oxidizing agent. Now, the question is asked, what is the N factor of KMnO4 in acidic medium? If they ask me what is the N factor of KMnO4 in which medium? In acidic medium. How exactly you are going to calculate this? Similarly, N factor of KMnO4 in neutral medium or slightly alkaline medium. Similarly, N factor of KMnO4 in strongly basic medium. How do we get all this? How do we get all this? It's again simple. Have a look. In acidic medium, +7 to +2. Calculate the change in the oxidation state, which is final oxidation state minus the initial oxidation state. The value comes out to be 5. This 5 is the change in the oxidation state for one atom of manganese, and here I've got just one. So 5 multiplied by 1 comes out to be 5. So remember it directly from now onwards. N factor of KMnO4 in acidic medium is 5 directly. N factor of KMnO4 in acidic medium is 5 directly. Now talk about the neutral medium. In neutral medium, it goes from +7 to +4. Initial, final. So it's going to be final minus initial mod. The value comes out to be 3. And this 3 is the change in the oxidation state for one atom of manganese. So I'm multiplying this with 1, right? 3 multiplied by 1 is 3. N factor of KMnO4 in basic medium. +7 to +6. Calculate the change. Final minus initial. The value comes out to be 1. This 1 is the change in the oxidation state for one atom of manganese, and here I've got 1 only. So I'm multiplying this with 1 at the end. So you got the N factor as 1 over here. So my dear students, from this equation is asked. From this equation is asked. I hope I'm clear till here. I hope I'm clear till here. Yes? Right, people? So, you got the N factor of KMnO4 in all the mediums. If you got the N factor of KMnO4 in all the mediums, you can calculate its equivalent mass as well. So, what will be the equivalent mass of KMnO4 in acidic medium? It will be molar mass M divided by 5. Equivalent mass of KMnO4 in neutral medium, M divided by 3. Similarly, M divided by 1. Molar mass divided by N factor. That's all. Okay, I hope I'm clear. I hope I'm clear with this. I hope I'm clear with this. Yeah? Perfect. From this equation is asked, guys. From this question is asked. Anything can be asked. I believe you are going to remember all these things about KMnO4. Okay? For example, they'll ask you a question like this. What is the ratio of, calculate the ratio of equivalent mass of KMnO4 in acidic, neutral, and basic medium. Let's say you got a question like this. What will be your answer? What will be your answer? We are talking about KMnO4, right? We are talking about KMnO4, right? First is your acidic medium, then is your neutral medium, then is your strongly basic medium. And we got to know a few minutes back. N factor of KMnO4 in acidic medium is 5. Here it is 3, and here it was 1. So if you got the N factors, what about the equivalent mass? Equivalent mass of KMnO4 in acidic medium will be M by 5. Here it's going to be M by 3, and here it's going to be M divided by 1. So get the ratio. If you want to get the ratio, M gets cancelled. The value is 1 by 5. Here the value is 1 by 3. Here the value is 1 by 1. Now do one thing. Take the LCM of the denominators. When you take the LCM of denominators, LCM of 3 and 5 comes out to be 15. So multiply throughout by 15. 15 over here. Similarly, multiplying with 15 everywhere. When you multiply with 15 everyone, 5, 1, 5, 3. So 3 is to 3, 1, 3, 5. 5 is to 15. This is the ratio of the equivalent mass of KMnO4 in acidic, neutral, and basic medium. That is something I was supposed to calculate. Right? I believe I'm clear with this. Right, guys? Perfect. Now, this was about KMnO4. Now, there are some questions which I'm going to give you. and you are going to tell me their n factors. For example, you have got K2Cr2O7. Let's say K2Cr2O7, remember it, in acidic medium, it gets converted into Cr tripositive. I'm asking you to calculate the n factor of K2Cr2O7 over here, right? Let me mark certain questions. Let's say you have got C2O4 dinegative. For example, C2O4 dinegative gets converted into carbon dioxide. Tell me the n factor of this oxalate here. Let's say I'm writing the reaction like this. I2 gives IO3 negative. Tell me the n factor of I2 over here. Similarly, for example, I have got Fe2 C2O4 whole thrice gives carbon dioxide. You need to tell me the n factor of this particular species. Okay. For example, I have got H2O2 gives O2. Tell me the n factor of this particular species. These are the different questions which I'm giving you. For example, VO, vanadium oxide, gives V2O5. Tell me the n factor of this. For example, you have got Fe 0.930 gives Fe2O3. Tell me the n factor of this one. Let's say you have got IO3 negative giving IO4 negative. Tell me the n factor of this species. These are the different types of questions which I'm giving you. Can you let me know the answers of these questions quick? Quick, guys, quick. Everyone, quickly. Quickly, guys. You should be able to solve these questions, guys. This is simple. Understand carefully. First of all, when you calculate the oxidation state of chromium here, it comes out to be +6. Here it's going to be +3. +6 to +3. What will be the change? Final minus initial. The change comes out to be 3. 3 is the change for 1 atom of chromium, but I have 2. So 3 2s are 6. So its n factor is nothing but 6. Okay. If I ask you the n factor of this chromium tripositive, I'll be calling this as initial oxidation state. This will be my final. So final minus initial, the value comes out to be 3. 3 is the change for 1 atom. I just have 1, so its n factor is 3. Okay. I gave you the n factor of the reactants as well as products here. Look at the next question. Guys. Just a second. All right, look at the next one. If you look at the oxidation state of carbon here, it comes out to be +3. Oxidation state of carbon, when you calculate it, +4. +3 to +4. What is the change? 1. 1 is the change for 1 atom. I have 2. So its n factor is 2. Okay. +4 to +3. Change is final minus initial. 1. 1 is the change for 1 atom. I have 1 only. So its n factor is 1 here. Right? Iodine. Its oxidation state is 0. Here the oxidation state of iodine is +5. 0 to +5. 0 to +5. Calculate the change. Final minus initial. The value comes out to be 5. 5 is the change for 1, but I have 2. So 5 2s are 10. N factor of I2 here is 10. Now, IO3 negative. Calculate its n factor. +5 to 0. Final minus initial. The value comes out to be 5. 5 is the change for 1. I have only 1. So its n factor is 5. Okay. Calculate the oxidation state of this carbon. It will be +3. This carbon will be +4. I need to get the n factor of this particular species. +3 to +4. Change. Final minus initial. 1. 1 is the change for 1 atom. But how many I have? 3 2s are 6. So 1 into 6 comes out to be 6. So n factor of this species comes out to be 6. Hydrogen peroxide. Oxygen -1. Here oxygen 0. -1 to 0. Change. Final minus initial. Value comes out to be 1. 1 is the change for 1. I have 2. So its n factor is 2. Right? Perfect. Similarly, what is the n factor of this carbon dioxide here? I'll be calling this as initial. This will be final. Final minus initial. The value is 1. 1 is the change for 1. I have only 1. So its n factor is 1. Okay. 0 to -1. 0 to -1. Change. Final minus initial. Commod. Value is 1. 1 is the change for 1. I have 2. Right? Look at this particular question. Vanadium, its oxidation state here is +2. Its oxidation state here is +5. I need to get this n factor. So this is initial, this is final. Final minus initial. The value is 3. 3 is the change for 1. I have only 1. So its n factor is 3. Okay. V2O5. What about its n factor? Call this as initial, call this as final. Final minus initial ka mod is 3. 3 is the change for 1, but I have 2. So 3 2s are 6. So its n factor is 6. Okay. Leave this part aside. Look at this one. This is +5 here. This is +7 here. So +5 to +7. Calculate the change. Final minus initial. The value is 2. 2 is the change for 1. I have only 1. So its n factor is 2. Similarly, its n factor will be also 2. Look at this particular example. What is the oxidation state of iron over here? You can calculate it. I've showed you. I've shown you exactly how to calculate the oxidation state of iron in this particular compound in the first session. If you remember it in the first session only, it came out to be +200 by 93. And I told you this is the average oxidation state of iron. Here the oxidation state of iron is +3. Now, I need to calculate its n factor. So I'll be calling this as initial, this as final. So it's going to be final minus initial, final minus initial ka mod. This gives me the change in the oxidation state for one atom of iron, but how many do we have? 0.93. So multiplying this with 0.93 at the end, this is going to give me the n factor of the non-stoichiometric compound, which is Fe 0.93. Oh, right? You can solve it, get the n factor exactly. I hope I'm clear with all of this. Yeah? All clear, people? All clear? All clear? I hope you can easily calculate the oxidation states. Sorry, I hope you can easily calculate the n factors of these oxidizing and reducing agents from now on. Okay? Perfect, people. All clear till here? Let me know once in the chats quickly. Let me know once in the chats quickly if all these things, if all this stuff is absolutely clear to you. Quickly, I would want your answers in the chats. Then only I'll move ahead. Then only I'll move ahead. Then only I'll move ahead. Quick. All right, guys. Now, how many cases of n factors we have discussed till now? So this was our sixth case. Now let's move on to the seventh case. Seventh case of n factor. In total, we have got almost 9 to 10 cases, okay? And this is very, very, very important. Again, I'm telling you. Redox titration will happen in the next session. Okay? Okay, seventh case. What is that? That is n factor. N factors of those substances. N factors of those substances which can act like N factors of those substances which can act like oxidizing agent as well as reducing agent. N factors of those substances which can act like oxidizing agent as well as a reducing agent. My dear students, there are some compounds. There are some compounds which in one reaction will behave like the oxidizing agent, and in some other reaction, it will behave like the reducing agent. There are some compounds which show the dual nature. In one reaction, they will be behaving like the oxidizing agent, and in some other reaction, the same substance will be behaving like the reducing agent, right? For example, you have got H2O2. Sometimes you will see H2O2 behaving like oxidizing agent, and sometimes you will see the same H2O2 behaving like the reducing agent. Number one. For example, you have got HNO2. For example, you have got FeSO4. These are the substances which show the dual nature. In one of the reaction, in some reactions, they'll be behaving like oxidizing agents. And some other reactions, they'll be behaving like reducing agents. Now, remember a few things. H2O2, in one of the reaction, you will see H2O2 getting converted into water. In some other reaction, you will see the same H2O2 getting converted into O2. Okay. Similarly, HNO2. Sometimes you will see this HNO2 getting converted into NO. And sometimes you will see this HNO2 getting converted into NO3 negative. FeSO4. Sometimes you will see it getting converted into Fe di positive. And sometimes you will see it getting converted into iron. Now understand what exactly is happening over here. Hey guys, this is something which is very simple. Understand. Oxidation state of oxygen here is -1. Here it is -2. Here it is 0. Now, -1 to -2. Decrease in the oxidation state. Reduction, so oxidizing agent. -1 to 0. Increase in the oxidation state. Oxidation, so reducing agent. So whenever you see H2O2 getting converted into water, understand it is behaving like the oxidizing agent. Whenever you see H2O2 getting converted into O2, understand it's behaving like the reducing agent. Okay? Right? Similarly, guys, look at this nitrogen. Its oxidation state here will be +3. Here it's going to be +2. Now, +3 to +2, decrease in the oxidation state. Decrease is a reduction, oxidizing agent. +3 to +5. +3 to +5, increase in the oxidation state, means oxidation, reducing agent. Right? For example, iron here +2. +2 to +3. Sorry, this is +3. +2 to +3, increase in the oxidation state, oxidation, so reducing agent. Similarly, +2 to 0. +2 to 0, decrease in the oxidation state, means reduction, so oxidizing agent. Right? So these are the three species. These are the three common species which show the dual nature. Sometimes they behave like oxidizing agents. Sometimes the same species behaves like the reducing agents. Right? Now, let's try to calculate their N factors. -1 to -2. Let's calculate the N factor of H2O2. Let's calculate the N factor of H2O2 when it behaves like the oxidizing agent. It will be equal to -1 to -2. Initial, final. Final minus initial. So mod of final minus initial is -1. The value comes out to be 1. 1 is the change for 1 atom of oxygen, and here we have got 2. So I'm multiplying it with 2. So its N factor here comes out to be 2. Right? Similarly, if you talk about the N factor of H2O2, when it behaves like the reducing agent, see, -1 to 0, initial, final. So final minus initial. Final is 0, minus. Initial is -1. The value comes out to be 1. 1 is the change for 1 atom of oxygen, but I have 2. So 1 multiplied by 2, here comes out to be 2. So N factor of H2O2, when it behaves like the reducing agent, it's also 2. Yeah? Now, look at the next case. +3 to +2. +3 to +2. Change, final minus initial. That's 1. 1 is the change for 1 nitrogen, now only 1. N factor of HNO2, when it behaves like the oxidizing agent, is equal to 1. Similarly, what will be the N factor of same HNO2 when it behaves like the reducing agent? Let's calculate it. See, +3 to +5, get the change. Final minus initial. The value comes out to be 2. 2 is a change for 1 atom, now only 1. So it's 2. Right? +2 to +3. What is the change? Final minus initial. It's 1. 1 is a change for 1 atom, now only 1. So N factor is 1 here. Similarly, +2 to 0. N factor here comes out to be 2. So my dear students, these were the three species. These were the three common species, I must say. These are the three common species, I must say, which have got the dual nature. Sometimes they behave like the oxidizing agents, and in some other reaction, they'll be behaving like the reducing agents, right? They'll be behaving like the reducing agents. So this was our 7th case of the N factors. Now, going to the 8th case. I'm writing N factor of those substances. N factor of those substances. N factor of those substances in which oxidation state of more than one element. In which oxidation state of more than one element increases or decreases simultaneously. Increases or decreases simultaneously. Its N factor is equal to N1 plus N2 plus dash dash dash. What exactly it means? What is this particular topic all about? This again, one more important thing. My dear students, till now, if you would have looked carefully, till now we were talking about those oxidizing and reducing agents wherein oxidation state of only one atom was changing. Till now, we were only talking about the oxidation. Till now, we were only talking about the N factors of those oxidizing or reducing agents wherein the oxidation state of only one element was changing. And we were calculating change in the oxidation state of that element, right? Till now, we were only talking about those oxidizing and reducing agents wherein the oxidation state of only one element was changing. Oxidation state of only one element was changing. And we were calculating change in the oxidation state of that element. Now, there can be certain oxidizing reducing agents wherein oxidation state of more than one element will be changing. There will be some oxidizing reducing agents wherein oxidation state of more than one element will be changing. Now, there will be certain cases. For example, you have got a compound in which oxidation state of two elements is increasing simultaneously. Let's say you have got a compound in which oxidation state of two elements is decreasing simultaneously. And right now, I'm talking about this category only. Whenever you see whenever you see a compound wherein oxidation state of more than one element either increases simultaneously or decreases simultaneously, how do we calculate this N factor? It's N1 plus N2. It's N1 plus N2. It's N1 plus N2. Okay? Let me take certain examples. Let me give you certain reactions over here. Just give me a second. Just guys, give me a second. I'm writing certain reactions over here, right? Basically, these reactions are questions directly. Okay? For example, the first reaction I'm writing, that is FeC2O4. It gives, for example, Fe tripositive plus carbon dioxide. Let's say this is my first reaction. I need to calculate N factor of this species. Okay? The second one is your Cu2S. Cu2S gives a Cu dipositive plus SO2. This is one more reaction. The third reaction, for example, AS2S3. It gives AS2S3 gives ASO4 trinegative plus SO4 dinegative. This is our third reaction. Similarly, the fourth one is your FeS2. It gives Fe2O3 plus SO2. The next reaction, Bi2S3. For example, it gives Bi plus 5 plus sulfur. These are few reactions which I've taken over here. Now try to understand what is important. Try to understand what is important here in all these reactions. These you can call as questions as well. I'm asking you to calculate N factor of this species here, N factor of this species, N factor of this species. Now how do we do it? First of all, guys, when you calculate the oxidation state of this iron here, it will be plus 2. This carbon, it will be plus 3. This iron, it will be plus 3. This carbon, it will be plus 4. Now look at this particular compound specifically. Look at this compound specifically. My dear students, in this particular compound, the oxidation state of how many elements is changing? If I ask you, if you look carefully, the oxidation state of iron is changing from plus 2 to plus 3. The oxidation state of carbon is also changing from plus 3 to plus 4. So this is the compound in which oxidation state of more than one element is changing. Now, how exactly it is changing? How exactly it is changing? Is the oxidation state of both the elements increasing? Both the elements decreasing? One increasing, one decreasing? What exactly? Check it out. Plus 2 to plus 3, increase. Plus 3 to plus 4, increase. And whenever you have got a compound wherein the oxidation state of more than one element either increases simultaneously or decreases simultaneously, how do you calculate this N factor? Simple, N1 plus N2, nothing else. N1 plus N2. What is N1? What is N2? Check it out. Plus 2 to plus 3. Plus 2 to plus 3. What is change? Final minus initial. The value is 1. 1 is the change for one end. And over here, I've got only one iron atom. Right? So N1 value is 1. What about N2? Plus 3 to plus 4. Plus 3 to plus 4. What is the change? Final minus initial. The value comes out to be final minus initial. That's 1. 1 is the change for one carbon. I have 2. So N2 value is equal to 2. So you got N1, you got N2. So N factor of this overall species here will be N1 plus N2, which comes out to be 2 plus 1. That comes out to be 3. So 3 is the N factor of this species. Simple. Now, if I ask you what is the N factor of this iron tripositive, if I'm asking about the N factor of Fe tripositive, then you'll be calling this as initial oxidation state of iron. You'll be calling this as final oxidation state of iron. So final minus initial ka mod, the value comes out to be 1. 1 is the change for one atom. I've got only 1. So its n factor is directly 1. If I'm asking you what is the n factor of this carbon dioxide, you'll be calling this as initial and you'll be calling this as final. So final minus initial, a mod. Value comes out to be 1. 1 is the change for one carbon and I've got only one carbon. So its n factor is 1. All right. Now look at the next example. The oxidation of copper here is +1, here it's -2. Here it's +2, here the oxidation of sulfur is +4, right? Now understand. +1 to +2. +1 to +2, increase. -2 to +4, increase. +1 to +2, increase, right? -2 to +4, increase. So oxidation instead of more than one element is increasing simultaneously. So its n factor will be again n1 plus n2. See guys, +1 to +2, change is 1. 1 is the change for 1, I have 2. So n1 value is 2. What about n2? -2 to +4, final minus initial. So 4 minus -2 is 6. 6 is the change for 1, I have only 1. So n2 value is 6. So 6 plus 2 comes out to be 8. So this is the n factor of your Cu2s. Now, this particular arsenic, it's +3, sulfur is -2. This arsenic over here is +5, right? And this sulfur is +6. Now understand, +3 to +5, increase. -2 to +6, increase, right? So again, its overall n factor has to be n1 plus n2. How exactly? +3 to +5, change is 2. 2 is the change for 1, I have 2. So 2 2s are 4. So n1 value is 4. -2 to +6, calculate the change. Final 6 minus initial, -2. So 6 minus -2 is 8. 8 is the change for 1, but I have 3. So 8 3s are 24. So n1 plus n2, 24 plus 4 makes it 28. So this is its n factor. I hope you are getting all these things. I hope you are getting all these things. All right, look at this FeS2. Look at this FeS2. So this will be +2, this will be -1, right? This will be +3, and this will be +4. Understand now. +2 to +3, increase in the oxidation state. -1 to +4, increase in the oxidation state. So if you talk about the n factor of this overall species, look carefully. Oxidation state of iron is increasing as well as oxidation state of sulfur is increasing. So I would say oxidation state of more than one element is increasing here. So its n factor has to be n1 plus n2. So +2 to +3, what is the change? Change is 1. 1 is the change for one atom. I have only 1. n1 value is 1. -1 to +4, what is the change? Final minus initial. The value is 5. 5 is the change for 1. I have 2. So 5 2s are 10. So n2 value is 10. So 10 plus 1 makes it 11. So its n factor is 11. And this will be your homework question. You will be letting me know in the comment section what will be the n factor of this Bi2S3 over here in this particular reaction. I hope all these things are clear to you. Yeah? So this was our 8th case. Now there are 2 cases left, and with that we'll end the session. Okay? 2 more cases and we are done. 2 more cases and we are done. Right? All right. So 9th case, people. 9th case is simple. I'll write n factor of those substances in which oxidation state of one element increases. Oxidation state of one element increases and the other one decreases. The other one decreases. The other one decreases. How do you calculate its n factor? Its n factor is going to be mod of n1 minus n2. Mod of n1 minus n2. Let me give you certain examples. Sir, 5 multiplied by 2 nahi kiya. What do you mean 5 multiplied by 2 nahi kiya? Where? I did it, right? 5 into 2 is 10. I did it already. I did it already. Yes? Okay. Anyways, we are looking into one more case here. Let me give you certain reactions. For example, you have got the reaction Fe2S3. It gives FeO plus SO2. Then, for example, we have got one more reaction. BaSCN whole twice. It gives BaSO4 plus HCN. For example, I'm asking you to calculate the n factor of this particular species and this particular species. Now understand to which category it belongs to. Understand to which category it belongs to. See guys, this is something which is simple, I would say. First of all, if you ask me what is the oxidation state of this iron here, it will be +3 and this will be -2. Iron here, when you calculate it, +2. Sulfur here, when you calculate, it's going to be +4. Okay. Now, +3 to +2, decrease in the oxidation state. -2 to +4, increase in the oxidation state. So can I say this is the compound wherein oxidation state of one element is increasing and another one is decreasing? There are two copper atoms in the third question. Which question you are talking about? There are two copper atoms in the third question. Which one was the third question? Third question is this one. There is no copper. You mean in the second question? Yeah, there are two copper atoms. +1 to +2. Change is 1. 1 is the change for 1. I have 2. And 1 is 2. That's what I've written. What are you talking about? What are you talking about? You'll be getting the notes in my Telegram, right? Which is Wasim Bhatt Chemistry Official. You can check it out. All right, we'll look here now. So first of all, this is the compound wherein oxidation state of one element is increasing, another one is decreasing. And whenever you see such kind of the compound wherein oxidation state of one element increases, another one decreases, its N factor is calculated as mod of N1 minus N2. Okay. Now get N1, get N2. +3 to +2. +3 to +2. What is the change? Final minus initial. Value comes out to be 1. 1 is the change for 1. I have 2. Right? So N1 value is 2. -2 to +4. Change is 6. 6 is the change for 1. I have 3. So 6 3s are 18. So its overall N factor is going to be this minus this. 6 into 3 is 18, right? This is supposed to be 18 here. 18 minus 2 comes out to be 16. So overall N factor of this is 16, right? Similarly, you can calculate N factor of FeO as well. For example, I'm asking you to calculate N factor of FeO. So you'll be calling this as initial and this will be final. So final minus initial value is 1. 1 is the change for 1. I have only 1. So its N factor is 1, right? You can calculate for this as well. By the way, BaSCN whole twice. I have given you its structure in the first session, wherein we have clearly seen oxidation state of barium here as +2. Sulfur here is a -2 oxidation state. Carbon here will be in +4 oxidation state. Nitrogen here will be in -3 oxidation state. We have seen it in the first session of redox, wherein I give you a lot of structures. Barium here is in +2. Sulfur, when you calculate, it's going to be +6. Now this HCN. HCN is like this. H, C, triple bond N. So C triple bond N, nitrogen -3, carbon +3. CH bond -1 +1. So nitrogen is in -3 oxidation state. Carbon here is in +3 -1 is +2 oxidation state. Now calculate each and everything. Try to understand. The oxidation state of barium is not changing here. +2, no change. So I've got nothing to do with barium. I have got nothing to do with barium. Now look at sulfur. Sulfur is going from -2 to +6. -2 to +6, increase. Carbon is going from +4 to +2, decrease. Nitrogen's oxidation state is not changing. -3, -3. Nothing to do with that. So this is again the compound wherein the oxidation state of one element is increasing, another one is decreasing. Now, how do you calculate its N factor? It's going to be N1 minus N2 ka mod. See, -2 to +6. -2 to +6. What is the change? Final minus initial. Value is 8. 8 is the change for 1 sulfur, but I have 2 sulfur. So 8 2s are 16. N1 value is 16. Similarly, +4 to +2. Change is 2. 2 is the change for 1 carbon. I have 2. So 2 2s are 4. This is 4. So this minus this is 12. So N factor of this BaSCN whole twice is 12. Right? Directly. Okay? If its N factor is 12, you can calculate its equivalent mass. Molar mass divided by N factor. Done and dusted. Right? Okay? So this was my 9th case wherein this is the case wherein the oxidation state of one element increases, another one decreases. Right? Perfect. Now, people, one last case which I'm going to give you here. That is the 10th one. That is N factor of a substance that undergoes disproportionation. N factor of the substance that undergoes disproportionation. Now, what is meant by the term disproportionation? What is meant by the term disproportionation? See, guys, before talking about disproportion, write it over here. N factor of the substance that undergoes disproportionation is equal to N1, N2 divided by N1 plus N2. What exactly it means? Try to understand, guys. Try to understand. For example, you have got the reaction like this. Let's say the reaction is A2 gives A positive plus A negative. Let's say this is one reaction. A2 gives A positive plus A negative. Okay. Now, first of all, let's assume that oxidation state of A here is 0, here it's plus 1, and here it's minus 1. So what is happening basically? Understand. 0 to plus 1, increase in the oxidation state. 0 to minus 1, decrease in the oxidation state. Can I say oxidation state of same element? Oxidation state of same element is increasing as well as decreasing simultaneously. Oxidation state of same element is increasing as well as decreasing simultaneously. And whenever oxidation state of same element increases as well as decreases simultaneously, we say that species undergoes disproportionation. And that species which undergoes disproportionation, how do we calculate its N factor? It's nothing but N1, N2 divided by N1 plus N2. Now the point is, how do we get N1? How can we calculate N2? Let's get to know. See guys, 0 to plus 1, 0 to plus 1, change, final minus initial, that's 1. 1 is the change for one atom, I have 2. So N1 value is 2. 0 to minus 1, what is the change? 0 to minus 1, change is 1. 1 is the change for 1, I have 2. So N2 value is 2. So it is nothing but 2 multiplied by 2 divided by 2 plus 2. The value comes out to be 1. This one is going to be the N factor of A2 over here. But if they ask you, what is the N factor of A positive? You'll be calling this as initial. You'll be calling this as final. Final minus initial ka mod comes out to be 1. 1 is the change for 1. I have only 1. So its N factor is 1. Similarly, its N factor is 1. Okay. For example, I'm giving you a question. Let's say the question is like this. Let's say the question is like this. Br2 gives Br negative plus BrO3 negative. Now, its oxidation state here is 0, here it's minus 1, here it's plus 5. 0 to minus 1, decrease in the oxidation state. 0 to plus 5, increase in the oxidation state. So I must say, oxidation state of same element is increasing as well as decreasing simultaneously. So this Br2 is undergoing disproportionation. So this is N1, N2 divided by N1 plus N2. Now, 0 to minus 1, what is the change? Final minus initial, the value is 1. 1 is the change for 1, I have 2. So N1 value is 2. 0 to plus 5, what is the change? 5. 5 is the change for 1, I have 2. So 5 2s are 10. N2 value is 10. So it's nothing but 10 multiplied by 2 divided by 10 plus 2. The value comes out to be 5 by 3. So 5 by 3 is going to be the N factor of Br2 here in this particular case. Okay. Similarly, there was one question asked long back in AIMS from the same concept. The concept is like this. I mean, you were given with the reaction H2O2 gives H2O plus O2. This was the reaction. The question was equivalent mass of H2O2 in the reaction is. Equivalent mass of H2O2 in the reaction is. Understand. Oxygen here shows minus 1 oxidation state. Here oxygen shows minus 2. Here oxygen shows 0. So minus 1 to minus 2 means decrease. Minus 1 to 0 means increase. I must say oxidation state of same element is decreasing as well as increasing simultaneously. So I would say this particular species is undergoing disproportionation. And whenever species undergoes disproportionation, how do we calculate its N factor? You know, N1, N2 divided by N1 plus N2. Minus 1 to minus 2. Change is 1. 1 is the change for 1, I have 2. N1 value is 2. Minus 1 to 0. Change is 1. 1 is the change for 1, I have 2. N2 is also 2. So N factor of H2O2 here will be, N factor of H2O2 will be N1, N2, N1, N2 divided by N1 plus N2. The value comes out to be 1, right? If the N factor of H2O2 is 1, so equivalent mass of H2O2 will be equal to molar mass of H2O2 divided by its N factor. The value comes out to be nothing but 34 grams. So this is the equivalent mass of H2O2 in this particular reaction which I was supposed to calculate. So my dear students, with this, our N factor calculation is done and dusted. With this, our equivalent mass term is done and dusted. And with this, I'll be taking a leave also. And there will be one more session on redox. That's going to be the last session, wherein I shall be discussing about Balancing of redox reactions, that's number 1. Number 2, redox titration. Those are the 2 topics which are left here in this particular chapter, which I shall be discussing in the next session. And the next session is going to be on, today it is Monday. Tomorrow it's Yavar sir session. Day after Tuesday, Wednesday it's HSB sir. So Thursday. So Thursday 7 p.m. it's going to be my session again. Okay. Thursday 7 p.m. it's going to be the last session of redox, wherein I shall be discussing about the balancing, number 1, balancing of redox reactions, and redox titration as well. Perfect. Again, 2 important topics which we shall be discussing in the next session. All right. And the DPP of this particular session, I'll be sharing it in my Telegram, and the Telegram ID, Telegram, you can search Wasim Bhatt Chemistry Official. Just join in. It's an open group, right? And right after this session, I'll be sharing the Telegram of this particular session. And do let me know in the titration is not difficult. Who has told you titration is relax? Still, you have not watched the session yet. Just wait for Thursday. Now someone is saying redox titration is not in NEET. Who has told you it's not in NEET? It is there in NEET. Have you seen the syllabus? Reaction of KMnO4 more salt, reaction of KMnO4 oxalic acid, right? All that thing is there in the syllabus, which is given in practical chemistry, right? Nowadays it's called as practical chemistry, which is basically your titration only. Okay. Balancing and titration will be done in the next session, which is going to be the last session. Perfect. Chalo, I'll see you guys exactly on Thursday 7 p.m. That's going to be the last session of redox, and I would want every one of you to join in live on that particular day, because this is going to be super important session, which will be for 3 hours, not only for 2 hours. Okay. Chalo. And do let me know in the comment section after finishing. Right? Do let me know in the comment section what exactly did you like the most in the today's session. Okay? Chalo guys. Take care. God